Thank you very much. Thank you again for the organizers to invite us for the first participation, our first participation in Langdev. It's a good opportunity to introduce ourselves. I apologize in advance because I'm going to talk about something like 20 years of work in 20 minutes, so I will try to make it as simple and fast as possible. So we are a French company, and we edit a general purpose graphical modeler, which is arKItect. And yeah, the general idea is to provide an equivalent of Google Map. Google Map, you know, you can go from abstracted view to local views and so on. And the idea is more or less to generalize this idea to information systems. And the vision is that the systems around us are hierarchical with interactions. It's nearly the definition of what a system is. System is made of subsystems in interaction. So we have a very system-oriented approach in the way we define and organize information. And this is why hierarchies, you will see, is in the center of what we do. So to explain a little bit of solution, the mother of all things for arKItect is arKItect Designer. So I don't know if I can use this one. Yeah, arKItect Designer is the tool to make all tools. And over the time, we have developed some applications. Our partners have developed some applications. Application for systems engineering. Application for planning projects. It's not only Gantt, it's really help planning a project from scratch if needed. And also application for building on infrastructure, which are, okay, something, it was a challenge we had, I would say, 3 years ago. And yeah, it was really something new and very interesting because we started to integrate two-dimensional maps into the modeling continuously, I would say, seamlessly. Everything is seamless. So about the theory behind, I have to explain a few things. There are only, I would say, 2 big ideas, which are not very complex for you, I imagine. Imagine UML, except you only have aggregation links, plus a little bit something which is the ability to say aggregation, it's a little bit too, it's not enough, I need messages. So I have to be able to say that something is produced or consumed. So these are the only rules we have, the only first-class citizen rules we have. Of course, we have extended extensible records for any type or class. We usually use the word type because we are not, okay, it can be type of class, no problem. Theoretical basis. This is a little bit harsh, I'm sorry. I will go through very, very fast. But the type system is more or less equivalent to finite state machine plus some properties. And the models we manage are like directed acyclic graphs, which are consistent with the type system. So it's just that, and it means it's quite clean from the theoretical point of view, which allows us to, for instance, export, import, or export our models into the coq-proof system, for instance, but we could do that in any inductive system. Yeah, something very important. Because the system is heavily based on hierarchical relations, we are making a heavy use of recursivity and pattern matching. And these are very, very important things. I mean, it's a very important driver of efficiency in everything we do, both for modeling and for coding. So it seems strange because from the object-oriented usual approach, we have no relations except from hierarchy and messages. So it means when you want to do something which is not in this couple, you have to encode it some way. But from a practical point of view, usually you succeed to do it quite simply. No arity, we manage this rather at the language level. No specialization, generalization, no subtyping. We just copy a set of attributes if we need. From a system point of view, usually when you have a hierarchy of systems, you can think of the human body. You look at the human, you look at the subsystems of human, you will see that the attributes are not the same at all. I mean, attributes are the same for a very specific case. For Windows, for instance, Windows systems, you have the same attributes for type on the subparts and sub-object recursively. Most of the time, in a system, the attributes of the different layers are not the same at all. So we don't suffer of that from a practical point of view. So very minimal set of rules. Okay, I just need to say I have a type. I can add attributes to a type. I can say a type contains or is parent of another. And I can say a type is produced or consumed by another. Very robust and stable core, because this is a very small set of rules. Low code, you will see, and execution on DAGs is, I would say, a killer, because it allows to define a lot of functions independently, completely independently from the DSL you are defining. Which means, once you define your DSL, a lot of things are here immediately. Okay, so I'm giving you a very simple example. If I want to talk about functional architecture, I will have a diagram like this one. A function may contain function, so instance of functions may contain functions. Requirements may be allocated to functions, and data may be produced or consumed by functions. And that's the way I'm defining functional architecture in the data model. Nothing more, nothing less. So every type system we define, they can be specified with these short rules. Okay? Typical user context. We were talking about Excel. A very, very, very good example. I would not say systems engineering is the only case. I mean, it's one case among others. Usually, organizations have internal tools, very often Excel-based, like small databases, specialized, focused on specific tasks. More and more what we see is now that there is pressure on skilled resources. This is something new. I mean, 2 or 3 or 4 years before, I had not this feedback, but now people are looking for efficiency. Don't ask me why. Then many unrelated documents managed by silos, so many communication problems, many issues, because you have a lot of specialized people who work on their own part, and they work on their own stuff, and it's difficult to work together. And from this, there is a need for collaborative data-centric approach with fast learning curve. So this is the point. Small demo. I'm going to show you the tool very quickly. So I am going to start from scratch. I will create a project. Okay. Okay. Sample 2 in that case. I don't know where it is. Okay. So here I am in a workspace. I'm defining the project, a space where I can. Okay. So sorry for that. I'm using a space where I have predefined formats and I don't use them. And now I'm going to do what I said. So if I come back to the PowerPoint, if you have it in mind, this is the metamodel definition. Okay. So we are just going to say that we are using functions. So I define a type function. Okay, maybe correctly. Then I can give a very small look and feel. I can say a function is in a function. I'm doing that. Okay, and I can say a function is exchanging data. I will simply say that. Data is a link, so just a hierarchy, but with a specific thing, okay? And I edit. And I've finished my data model for my simple application of functional architecture. So I'm going to produce a view to work with it. I am adding a filter. I say, okay, fun archi. Okay. And now I can work. I can edit my functions. I can put functions into functions. I can put data between functions. And data are objects, okay? If I expand this, I see the data is here, okay? Data is just an object like another, which means I can put something in it. I can add attributes. I can do everything I want. There is some possibility to add another functions, for instance, here. Okay, and you see the diagramming is updated instantaneously. I can add a new output, for instance. Okay, if the function is not consumed, you see that there is a question mark. Hey, where is it going? So maybe I'm going to add a new function. And I copy this as an output. So this is the power of messages. I mean, probably usually when you do this kind of drawings with other tools, we define ports and subports and things like that. Here, no way. We don't need that. We just drag and drop the objects. We reorganize the architecture as we want. Okay? So I would say most of the time, most of the time it's possible to do that. You have the tree view, the internal block diagram. I want just to feature a little bit the interface with Excel. So I'm adding a new function here. I can look at it from a table point of view, export it. So I like Excel too. So if you already have data in Excel, you just put into the system. So if you have flows, let's say D1, D2, D3, you need to say if there are inputs and outputs. Let's say input. Okay, and if you have functions or subfunctions here, let's say it's F1, F2, F3. Whoop. Okay, close it, re-import it. Okay, he asked me, do you really want to do that because you are going to overkill everything if there is already something in the functions? Okay. And now if I come to the internal block diagram, I have my new function F4. So each time if I look at an object, I see what's inside the object, you see. And if I come back at the top level now, I have F4 with all this bunch of flows, and I can allocate them very easily as usual. Okay, I have a problem with my pad. Up. Copy as output, for instance. If you want, okay, let's copy all of them, but you could copy a subset. Okay, so this was just to show you how it's possible to edit, import very easily data, okay? So coming back to my presentation, yeah, what we could do is that we could change a little bit the data model. We could maybe add a description. Just want to show you something as an introduction to next step. So here you see, as a list of attributes, you can define description, rich text, memo, markup language, which allows to make links to other objects. So this is another way of making links to other objects from an object, because you can point to it. You could have a program, which is a Python program, which can operate on the structure itself. You can have saved files, which means the files are stored and managed in revision management directly. So we have cases where we can really use this tool like a document management system, not only a model, okay? So I'm going to take a memo here, or it could be a string, okay. And of course, if you change the data model, you need to update your architecture. And now if I look at the property of the model object, I have a description and I can say my desk. Up. Okay. And the point is, I can manage in version, in revisions, my object with its own properties. So every object individually in the model can be managed in revisions, okay? So I'm going to show you in the next slide how I can perform configuration management and what it means for us. Maybe show a little bit of history, add something in mind. Okay, I will come back later, maybe. So as for the baseline, okay, just a few minutes, but I did not configure it, so I took another example. I feature this baseline features because it's something very powerful. Baseline is used to develop configurations. So this is an example of a baseline where I have a site, okay, on a set of requirements, and you see here stars 1.0. This is the revision number of each requirement. So this framework is used to manage a configuration, a set of objects. If I have a specification, for instance, I want to say specification for my system. It's version 2 of this requirement, version 3 of this one, maybe later, of course. And at some stage, I say, okay, boom, I put a stamp, and I will link to the chain here the version of each object inside the tree. And I could do that for any kind of tree. I do that for requirements here. It could be for any part of the hierarchy in the system. So this is a very powerful tool for configuration management, which means once you have done this, you can generate, for instance, this, and you have a hard copy of it somewhere in a SVN server for us. And when you want to come back to it later, you know what you have sent with this configuration. Okay. So just a few examples, interesting examples of the application of this technology, especially for 2D diagrams. So this is an application for building and constructions, on infrastructures. I will not talk about railways and so on, but we can do that at the site level as well. So here you see that we have a functional view of areas and objects. And we work a little bit, and then we can generate more or less automatically this 2D implantation, which starts to look like a level in a building. And then we have an export to Revit today to just have a very quick feedback of a 3D design corresponding to all the levels we have. And this is fully defined with the simple rules I've explained to you. The only special thing we have here is that we have a 2D diagrams, which has a scale which is really in which we manipulate distances and everything like that. So this is a very short demo. I think it's 2 minutes. Is it affordable? Yes? It's 5 minutes yet? Yeah, it's okay. So you have seen, okay, I'm starting again. So this is an example in the construction engineering. We have a process. We start from a process from a customer, and then sometimes, and very often, the processes are allocated already into rooms. This is into tables for interfaces. You read this from line to columns. It says interfaces. It's very fast. Then you import this file into the model. You see the boxes here. They correspond to the areas in the first side. The inputs and outputs, they correspond to electrical consumptions. And then we start to make a drawing which looks like the design of we want for the level here. It's a very simple example, a cocoa plant. And we just adapt the size to have a look and feel which is close to what we would like to have in the 2D diagram later. So just a fast way to prepare for a design, okay? Here we had a technical room where we are going to define, to add a provider for the electrical needs of all the equipments which are hidden in the areas here. So we have a library, we are looking to, sorry, the TGBT, CT8 French terms for electrical table or electrical power equipment. And we can allocate then the needs in electricity to the power equipment. Okay, and when this is done, we can allocate on this onto a level, so a site, a building on a level in a building. Just drag and drop, like this. And the design will immediately look like this. Then we have some programs to automatically add networks, walls of different kinds. We have 20 types of networks, and you export a kind of bit of quantity that allows you to make an estimate. This is the kind of application we have. So here you have length of cables. You could have sections as well in this. And you also have a volume of concrete needed for the construction of what we have done so far. Okay? Then another application which will be interesting to you, if I have 1 minute or two. Okay, it's application to project planning. And we started to work on this with the aerospace industry, with Thales Alenia Space, more than 10 years ago, nearly 15 years ago. But we started to accelerate 2 or 3 years ago on this topic. And now we have a full application for definition of a planning from a product tree and from allocation of some kind of life cycles to products. So I'm going to show you a small demo for this again. And this one is interesting because it includes some application of artificial intelligence already, which is, I would say, really impressive. It's something new. So here we are going to start with a chat. It's not the normal use, but here we ask for a solar plant of 50 megawatts in France, close to Aubagne. Aubagne is a town in the south of France. Okay? So we just launched that, and we interact with ChatGPT in this application with very targeted questions according to our process. And the process is to first try to get a project background structure, then a set of milestones, then to say for each product which kind of life cycles we are going to use. I mean, think of the V life cycle. I mean, design, build, install, test. And then for each of these activities, we want to have an estimate in cost, time, and we also want to, not only cost, time, workload as well, and we want to know exactly when it can happen with respect to the milestones. Okay, you see? Okay, it's a process. It's a process that we have structured and implemented in the tool. And the data model behind is quite simple, you know. And what is very impressive is that, okay, ChatGPT is avoiding us a lot of work, at least for doing the sample, but it's not that bad. We checked that against professionals in different domains. And this is the view of, it's going very fast. Yeah, okay. I would like just to show, where is it? No, I want to go and look at this. Yeah, just to explain. So this is a synthesis. So this corresponds to the first level product. This corresponds to the job functions, efforts, workload, cost structure, okay? And this kind of application is just performed with Matplotlib over the technology. Okay, so with the summary, we have compact data model with very simple views, generative views. So the views are generative. Each time you do something, you do it in the center, in the database, and all the views are updated synchronously. Viewpoints are natively consistent because they are top-down. Top-down and bottom-up because you may have existing objects with their interfaces and integrate them. Functional chains, which means you can build partial views on demand for specific aspects. Metamodel dynamic aspect, you have seen. I can change the data model and see the impact in the model just in time. Revision management, configuration management implemented. Option variants, I did not show it. Collaborative multi-user, low code, and full Python API. You can do everything we can do in the model. You have APIs to do it. Thank you very much.
Questions? Thank you very much for your presentation. I'm very new to Israel and all these tools, so I know almost nothing. Is this tool completely private? Does it have any open source software or free open?
So it depends. If you are academic, there is no problem to provide you with the tool. It's not open source at all. We developed it from scratch with our own means. With private business only. And also some collaborative project at the beginning. But we have a lot of industrial applications. We have customers who are using it for some project for more than 10 years on regular use. So we have quite a feedback, and I would say the platform is quite stable, really no real crisis or problems since 2017, I would say. You're welcome.
More questions?
It's very impressive, to be honest, to see all this. I was not aware of all the details there, and you're trying to recall any completion terms. That means it's not feasible. Still, if you look back on all the work you did, what was the key decision that made this work in the end? That made you successful?
I think it's very simple. It is the root. I mean, I had the chance to work in a very good computer science laboratory 35 years ago. And then I spent 10 years in the industry. And I had the idea of this tool because I noticed I was responsible for ESTA tools and methods work package. ESTA, if you remember, is maybe the project where AADL was produced initially. So I was in that stuff, and I was working on similar tools internally for my employer at the time. So I made a tool based on database, on many interfaces in the past at this moment, and I noticed that there was a pattern. I mean, whatever the view, whatever the domain, whatever what I do, I have always the same views, the same needs, same organization of information. And I said, with my researcher's mind of the past year, I would say, okay, in fact, there is a small pattern which would allow to do all this and even to apply this to other domains. So I think simply I observed that, and at the same time, most of the community was already in object orientation and very big complex things. And at the time, I was more from the functional programming community, type systems, and okay, object orientation is interesting, but I was more focused on ideas of doing a very simple thing, which would be very powerful up to recursivity, which is what I've learned when I was a student and afterwards. And now, if you look at the recent years, recursive structures with artificial intelligence, it's in the mood, and functional programming as well. So I would say it was simply a different path. And if I look at Eclipse EMF GMF, we tried to make a comparison recently. It's so complex. It's so powerful. You can do everything you want, okay. But the problem is that you can do everything you want. So how to find the path? Here, the path is defined in the basic rules we have chosen from the beginning. The path is that every system is made of systems in interaction. So the basic thing you need when you describe a system, when you represent a system, when you do whatever you want on a system, is to manage correctly hierarchy on interactions. And interactions are not an easy thing. We all know that a very small node here could interact with another node here. But anyway, this is exactly the format to capture this. Nothing less, nothing more.
Let me reverse my question.
Yeah, sure.
You being, it looks that you're successful with your colleagues in trying to sell your tool, but I'm wondering if this is no approach, real solution. Why aren't more people using this approach? So why are people not following your lead in the tool and the methodology that you promote?
It's very clear that we don't speak a lot. So, for instance, first participation in Langdev, I didn't even know the conference. Benoît Comtemal told me about this conference. That's why I am here today. And I know Benoît Comtemal for 1 year. So we had not curiosity to identify the community. And we were more working up to now on contact basis, I would say. Contact of contact. This is how the business happened to us. And in fact, when we try to talk with people from the object-oriented community, discussion is difficult. So we had to invest some time to understand really what Eclipse is today. Eclipse EMF GMF. We are using Eclipse for Python for our own sake, but Eclipse EMF GMF. We understand what it is, and we see a lot of community, a big part of the community is using it because it's free, open source and free. So open source and free seems to be magical words. Okay, guys. But if you spend 10 times or 50 times more time to do something than in a simple system like that, what's the purpose? I mean, we all made that with very limited means. I mean, when I say limited means, I mean really nothing with respect to what is spent on other technologies today.
That's why anyway, I think there's a lot of things to talk about. Thank you for your presentation.
But maybe we can share on this, and maybe this is a good idea also for this community.